Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to finally finish this chapter 3 review. It is a review sheet with 24 problems. We've been working really hard on the first 3 videos. We are now on the fourth and final video of this section. We have 1 word problem and 2 nonlinear systems. So in this particular case, you are allowed to use a calculator on this worksheet. The instructions do say you can use your graphing calculator to answer the questions. So I will lead you up to as far as I possibly can with these problems. And then I will hopefully expect that you know how to use your graphing calculator at this particular point in time. So without further ado, the first problem in this particular worksheet is a word problem. As you can tell here, we have a juggler. It's broken up into 2 parts. And then the other 2 problems, we're going to actually stop sharing this screen, share a different screen so that you can see what those graphs look like and so that you can actually understand what the concept is coming up with. Okay. So a juggler tosses a ball into the air. The ball leaves the juggler's hand 3 feet above, that should say above the 3 feet above the ground. And it has an initial velocity of 20 feet per second. So then it says use this equation, and part A says write a quadratic equation that represents height h of the ball t seconds after it is hit. So when we use this equation, we're actually going to say hey, this is my initial velocity and this is my initial height. That's the VO and HO business. So when we look at our initial velocity, we're told that it has an initial velocity of 20 feet per second. So my VO is going to be replaced by 20. When we look at our initial height, we know that 3 feet above the ground is an initial height. So my HO is going to be 3. So for part A, if I were to rewrite this equation, I would end up with H equals negative 16t squared plus 20t plus 3. So that's going to be my answer to H. For A. My answer to B is going to be a little bit different. Let's see what it looks like. The juggler catches the ball when it falls back to a height of 4 feet. So I know that the height was important in the earlier problem, so I'm probably assuming that the height is important again. How long is the ball in the air? So on your graphing calculator, you should be able to see where this particular graph is when it hits 4 feet. One of the things that I would recommend is, hey, my initial height is at 3, right? And so since my initial height is at 3 feet, I know that that's 0 time after the ball has left the juggler's hand, right? The ball, so let's say I'm holding a ball, I have a pen in my hand. I know that this ball is going to leave my hand as I throw it up into the air. It goes up into the air, eventually it goes off the screen, and then I can bring it back, it'll fall back down, and I'll catch it not when it's at 3 feet above the ground, when it's 4 feet above the ground. So I want to know how long did this ball spend up and then goes down. The first thing that I would do is I would say, okay, what happens when the ball is 3 feet in the air? 0 seconds, okay? So for 3 feet in the air, the ball has been in the air for 0 time, 0 seconds. In order to figure out what time, how long it's been in the air at 4 seconds, we're going to put 4 equals negative 16t squared plus 20t plus 3. Because we're looking for the time, right? So since t is what we're looking for, since time is what we're looking for, we're going to leave t as that variable. The next thing that you're going to want to do is you're going to want to put all of this into either your graphing calculator or Desmos so that you can see where that particular piece it graphs. I have a feeling that it's going to be not quite as easy to graph this. It'll likely have a radical. All right, so when we look at this particular function and when you use your graphing calculator, what we are going to do is we're going to have this particular graph on our graphing calculator. And so what I just did is I zoomed in so that I can actually see where I am located. This point right here is going to be 0.05224. If we want to know how long the ball has been in the air, we're going to start, starts at 3 feet. That's when we throw it. And then at 4 feet, this is going to be 0.0552. So this is kind of like when I've thrown it up that 4 feet. I'm looking more at this 4 feet. So this 4 feet seems like it's going to be 1.2. I'm going to go ahead and stop annotating just so that I can see where we are. Oh boy. So it's about 1.2. Hopefully I can get it. Yikes. So it's about 1.2, 1.1978. That's roughly 1.2. So we can say that the ball has been in the air for about 1.2 seconds. That's totally acceptable. That's how I would read this graph. That's how I would read that information. So in this particular case, we're going to have 1.2, 4. The ball has been in the air for 1.2 seconds. Okay, let's take a look at the other two problems. So the first problem that we have is this one, where you're given these two equations, y equals this, y equals that. You're asked to graph it, and then you're asked to figure out where these two solutions are. In fact, we are looking to estimate to the nearest hundredth. So I know that they meet at this point here and at this point here. So when I'm looking to solve a system of equations, I'm just looking to have them kind of in that same where my two lines meet, whether they're curved lines like these parabolas or whether they're linear functions, totally fine. So all you would do is you would graph those two and then go ahead and estimate to the nearest 10th, or not estimate, round to the nearest 10th, and you should be fine. So this would be negative 1.2, comma, negative 2.7. This would be 0.4, comma, 1.7. The other graph is same principle. We have two graphs. They are a little bit different because this one has like a stretch of 2. This one has a shrink of a half, right? But we're still looking for these 2 points where these two guys meet. And so we're still rounding to the nearest 10th in order for us to be able to see where our two graphs meet. And that's it. So the calculator portion is going to be a little bit more basic because all you're doing is plugging in the information and then going into graph things. You're going to need to know how to use that graphing calculator. And since all graphing calculators are a little bit different, that's a video for a totally different time. Okay, so I will see you in another video. Don't forget to send me some problems so that I can do those for you. Bye.